This problem deals with the change of order of integration and then evaluate the double integral 0 to 1 x to 1 x by x square plus y square dx dy. We will quickly recollect the 4 steps which is required for the change of order of integration. First, we will have to check for the direction. If it is going to be wrong, then you will have to change the direction and then rewrite it in the right format. The second one is going to be identify the region, and then you will have to sketch the region. When you are sketching, make sure you use 2 colors to distinguish between the axis of reference and the usual boundaries which has been given as the limits. The third one is going to be when your new region has been sketched out, you fix the new limits. How to fix the new limits? From the given order, you change the order and then you fix the new limits, either by drawing a line parallel to x-axis and moving from left to right, or drawing a line parallel to y-axis and moving from bottom to top. And once the new limits are being fixed, the final step is to evaluate using the new limit. Okay, so now we quickly move on to step 1 to check whether the given direction is going to be right or wrong. We have the variable limit first and then followed by the constant limit. Variable limit is from x to 1. X cannot be the limit of x itself because this is going to be absurd. So y has to be taking the limit from x to the upper limit called as 1. In which case, by default, this is your function to be evaluated and this is going to be the question. But we need to rewrite the question because since y limit has been given first, this has to be written as dy first and then followed by dx. So first step, we check the direction and we change it to suit the given problem accordingly. Y varying from x to 1, x varying from 0 to 1, the function being x by x square plus y square. So since y comes first, rewrite it as dy first and dx. So this is our given problem. So given direction is in the direction of y. Direction of y. Okay, the second step which we have to do is identify the region. The regions are given by y equal to x, y equal to 1, x equal to 0 and x equal to 1. In which case, to choose 2 colors to suit your axis. So let me choose my axis. Let this be our x-axis and let this be our y-axis. And now the given lines are sketched in a different color. Say we will go for x equal to 0, which represents our y-axis. So y-axis I am going to draw using this red color now. Okay, so this is going to be my x equal to 0. Next comes x equal to 1, which is going to be a line parallel to your y-axis at a distance of 1 unit. So in the same direction as how you have drawn your x equal to 0, you can draw your x equal to 1. So this is our x equal to 1. Now going for the third one, y equal to 1, y equal to 1. So the same distance over here, you move the same distance over here and you draw a line so that we have the line now called by the name y equal to 1. And now to get the line y equal to x, put the value of x over here. So when x takes the value 0, y also takes the value as 0. When x equal to 0, you also have y equal to 0. Now put the next point over here. When x equal to 1, y also takes the point 1. So 1, 1 and 0, 0 are the points through which this fourth line passes through. Now the origin is marked as 0, 0. The point over here with intersection of x equal to 0 and y equal to 1 is 0, 1. The point over here, the intersection of x equal to 1 and y equal to 1 is 1, 1. So now we know that the new line, which is y equal to x, passes through these 2 points. Now connect these 2 points by means of a line. So this is going to be my line, which is given as y equal to x. So this is my line, y equal to x. So now you can see that the region which is going to be bounded by all the 4 lines is going to be, which we'll see that This is going to be unbounded, so this is not going to be our space. This is unbounded, not our space, unbounded, not our space, unbounded. This is unbounded, and see, this is a black color, so it is not a part of your given limits. So this is an unbounded region, so you are not supposed to choose this lower triangle. In case if you are using the same color pen, then you will be in a dilemma whether to choose the upper triangle or lower triangle. So to avoid it, please use two distinct colors. Now we can come to a conclusion very clearly that the lower part is not a part of my given limits. Okay, so this is going to be an unbounded region, and so the bounded region is just the inner part of it. So the given region for our integration is going to be this portion, which is available as triangle. So this is our region of integration. So now our limit step number 2, which is going to be identifying the region and sketching the region, is done. So we move on to the third problem, which is third step, which is going to be fixing the new limits. How to fix the new limits? So the given problem, we see that the given problem is in the direction of the y-axis. So when you are going to change the order, then the problem now gets converted to a problem in the direction of x. So when you change, the problem in y now changes to a problem in the direction of x. So how to fix the limits in the direction of x? The third step is fixing the limits. So direction of x, which is the direction of x? You can notice that the x-axis is always drawn with the arrow over here. So which is the direction of x? The direction of x always moves from left to the right. So you move from over here to here in this direction. This is your direction of x. So what you do is, within the region which is going to be bounded, which is going to be your shaded region, you will have to draw a line parallel to your x-axis. Draw a strip parallel to your x-axis. So which is the beginning point? Leftmost point of your shaded region. This is your x equal to 0. From over here, start, and then you draw a line parallel to your x-axis. So you move from left to the right. So when you are moving from left to right, you quickly fill all the spaces over here in the direction of x. So now our direction of x is fixed. Now we are ready to fix the new limits. The new limits will have the limit to begin with x. That is, the variable limits are now for the variable x. Now what is the leftmost point of x? X begins the journey at 0. It moves and moves, and where does it end? It ends at the point y equal to x. When y equal to x, x takes the final value as y. So your limit for x is now getting fixed as 0 to y. So the variable limit for x comes between 0 to y. Now moving on, you go to fix the limit of y. Limit of y will now become the constant limit. What is the constant limit? The total height of the diagram is from here to here. Now check for the lower limit of y. Where does your y begin? It begins with 0. You move towards the top for the direction of y. Where does your y end? It ends at the line y equal to 1. So your y varies between 0 to 1. So the new limit, which was 0 to 1, x to 1, is now changed to 0 to 1, 0 to y. Notice, please pay attention, change of order of integration doesn't mean to replace the variable x by y and replace the variable y by x. See, notice we are not replacing this x as y or y as x. We are not doing that because it is entirely different. You sketch a new region and then you fix the limit in the given opposite direction and then you evaluate. So please don't do the mistake of just replacing the variable wherever you have x by y and y by x. Draw the region, fix the limits by drawing a strip parallel to your required axis. Now the function remains the same as x divided by x square plus y square. With respect to x comes first, so dx and then dy. So we move on to a new sheet to solve it, which is the step 4. Step 4, evaluate. So what you are going to evaluate? 0 to 1, 0 to y, 0 to 1, 0 to y. The function to be evaluated is x divided by x square plus y square. The values is going to be, sorry for it, here the limit is going to be from, the limit is be from 0 to y, 0 to y. So here the limit is from 0 to y. So you go for it. The limit is from 0 to y. The function is x by x square plus y square. So x is the limit, so dx comes first. Next is the y limit, so dy comes next. Now whenever we are going to integrate, the integration is from inside to outside. So inside, the first variable x gets evaluated. X is both in the numerator and denominator. So how to use or apply this integration? Recollect that whenever you have a function f of x and its differentiation in the numerator, then this is equivalent to taking log for your denominator. This is an important formula which we have learnt in our low grades. If the function is there and its differentiation in the numerator, then we can take log to the denominator. Now we can notice that with respect to x, y is a constant temporarily, so don't disturb it. So what is going to be there along with the constant? X square is there. So x square, when you differentiate, differentiation of x square is 2x. You have a x on top, what is missing is just a 2. So you balance it by multiplying and divide by 2. Now we are done. So that the limit now, differentiation of the denominator is in the numerator. So when I integrate, what is the answer for it? It is going to be log of f of x. What is log of f of x? X square plus y square. So now we are done with the first integration between the limits 0 to y. And still we have y varying from 0 to 1 to be integrated for dy. Now apply the limit. The limit is for the variable x. X takes y and x takes 0. So you will have log of y square plus y square minus log of 0 plus y square. So this has to be integrated with respect to y between the limit 0 to 1 and half is a constant. So you will have log of 2y square minus log of y square to be integrated between 0 to 1. Okay, so now attention over here. We have something of the format log AB. What is log of AB? Log of AB is nothing but log A plus log B. So when you are using this identity, what will happen? This function will now turn out as log 2 plus log of y square minus log of y square. Now see the magic happening. This can be cancelled off and then we are just left out with log 2 for our integration. So we just have half times integral 0 to 1 log 2 dy. Log 2 is a constant with respect to y. So what happens now is you have half integral, log 2 to be integrated. Log 2 is a constant, so that can be taken outside. So you will have integral from 0 to 1 dy alone. So you have half log 2 y on integration. Dy gives you y between 0 to 1. When you apply it, it is half log 2. This can further be simplified as log 2 to the power of half, because we know that a log b is nothing but log b power a, and further this is nothing but 2 to the power of half, so I can write it as square root of 2. So the change of order of integration primarily helps to solve the problem easily. So if you would have solved it in the direction of y, maybe it would have been very complicated. So we turn it in the direction of x to make it easy. That's it for the change of order of integration.